The next type of problem we see in the application problems are one that involves mixtures. On example 2, we have a nurse that wants to mix 60 cc's of a 50% saline solution with a 10% saline solution to dilute the saline to a 25% saline solution. How much of the 10% solution should he use? For the picture on this, imagine that we have a bottle of saline that is 50% saline, and we're going to mix that with, we're going to add that to the 10% saline solution, and we want that to result in a solution, an amount, and that's going to be measured in cc's, that is 25% saline. Again, like we did on the investment problem, the interest problem a minute ago, I like to put percents on the outside. This is percent saline, whereas it was percent interest rate on the last problem, and on the insides I like to put amounts. So what we know from our problem is that the nurse has 60 cc's of the 50% solution. What we don't know is how much in cc's of the 10% solution should he use. So that's going to be our unknown x cc's. Let's remind ourselves that we let x be equal to cc's of the 10% saline solution. Now, if we add 60 cc's to an unknown x amount of cc's, what we're going to have with the 25% saline solution is 60 plus whatever we added, the unknown. Now, in a mixture problem, once you get all of the percents on the outside and amounts on the inside, to get your equation set up that we're going to use to solve this, it's a matter of taking percent times amount. So we're going to write 0.5, or you could write 0.50 of the 60 added to 10%, or 0.1 of the, we don't know what this is, x. That's going to result in 0.25, 25% of the mixed quantity. That's the 60 plus the unknown amount of the 10%, the x. That's how you set up the model for these mixture problems. Now it's a matter of solving this equation. 0.5 times 60 is 30, plus 0.1 times x is just 0.1x. Here we need to clear the grouping symbols by using our distributive property. 0.25 times 60 is 15, plus 0.25 times x is 0.25x. Now let's move constants to one side, variables to the other. So I will subtract 15 from both sides. I decided to move it this way just so I would be dealing with positive quantities. If I'm going to subtract 15 and move my constants to the left-hand side, I'm going to subtract 0.1x so that I move my variables to the right-hand side. 0.1 is the same thing as 0.10, true? Okay, so 30 minus 15 is 15. Remaining on the left-hand side. On the right-hand side, 0.25x minus 0.1x is 0.15x. Solving for x, because we want to get how many cc's of the 10% saline solution we need, we're going to divide both sides by 0.15. And so, on the left-hand side, we have x remaining. That would be the right-hand side, actually. On the right-hand side, we have x remaining, And on the left-hand side, when we take 15 divided by 0.15, that gives us 100. Let's write the label. It was 100 cc's of the 10% saline solution.